Hi, I'm an old guy and I do maths. And today we've got a really interesting problem. Part of which you can see worked out already. But let's just go through this and ignore the fact that I may have spoilt a surprise. We have a curve with an equation of this, which is a cubic. Um, and we're asked to find the gradient of a chord, PQ. Now, a chord is simply a line segment that connects 2 points on a curve, where the first part of this, the first point rather, is 1, 0, and the second, Q, is this expression here. Now, those of you who are familiar with it will recognize this as a form from differentiation by first principles, which can be a bit tiresome to work with, but we're just going to try and solve this as best we can. And what I do want to emphasize is that we're looking for an expression, not a number. The fact that we have this here tells us that we are probably going to wind up with an expression. Okay, so the first task, which is already done here, is to deal with this part of the problem, expanding this and getting this into a single workable expression. Okay, so if we recognize that this is an x coordinate and this is a y coordinate, I've just popped these little things up here to remind you. As I said, we're going to expand and sort out this expression. So just let me quickly talk my way through this. So the easiest way to expand this is to square this expression, a perfect square. It's very easy to do. 1 squared plus 2 times 1 times h plus h squared. So 1 squared, 2 times 1 times h squared. And then multiply through again by 1 plus h, which will give us our cubic. And when we do that, what we get is we get 1 cubed, which is 1, plus 3h squared plus h cubed. And I've not forgotten this expression, but I need to get this sorted out before I can deal with this. Now, we have this sorted out. So what do we do with this? Well, we subtract 1 from it, so the 1 goes missing, and we subtract h from it, so 3h becomes 2h. So this expression here, which I'm underlining in red, is this. And that's it all sorted out. Now, given that differentiation by first principles is basically a form of rise over run, what we have is function of x plus h minus function of x. Now, function of x plus h is this thing. If x is what we're dealing with here, so in this case it's 0. So I'm going to fill this in red so that you can see all of what's going on. And by the way, this is over h, as h tends to 0. But the other thing to say is that before you get to this point with the gradient function, what you have is you have the x values of your coordinates, which will be 1 plus h and 1. So underneath here we have 1 plus h minus 1. Minus 1 we get from here. Okay, so that's essentially our gradient function. Now let's tidy that up. We are very close to getting to a solution for this. So 1 minus 1 is 1. I'll do this in blue. 2h plus 3h squared plus h cubed minus 0 is, of course, nothing. It makes no difference. 1 minus 1 is 1. This is all over h. And we can tidy this up by dividing through by h, because as you're aware, h tends to 0, and so you don't want to make the mistake of saying, well, h equals 0, so I'm just going to replace h with 0. Everything will turn to mud on you if you do that. You have to think about the order in which you do things. So what we're going to do is we're going to divide through by h, and we're going to get our solution. So that gives us 2. That cancels. That gives us plus 3h plus h squared. And that is the gradient of the chord that we've been looking for. That is our answer. Okay, I hope that made sense and that you found it useful. I've been asked about problems like this quite often, and there are probably 2 key elements. One is recognizing that you're going to be using the gradient function, and the other is to recognize that you're probably going to get an answer that looks like this. Right, thank you very much for watching. If this was useful, please like and subscribe, and I'll see you next time. Bye.